Okay, hi everyone. Today we are working on graphing secant and cosecant. So secant and cosecant, which is really, this is us really graphing cosines and us graphing sines. Okay, so remember the cos don't go together, so cosecant goes with secant, and no, cosecant goes with sine, and secant goes with cosine. Okay, so careful. So secant is really a cosine graph, and cosecant is really a sine graph. And we're going to start over here with the cosecants first. So let's go back and refresh ourselves. It's been a long holiday, and you guys probably don't remember anything. But let's talk about graphing sine graphs. And then from here, we'll jump to cosecant graphs. So to graph a sine graph, let's say y is equal to 3 sine of 2x, and we'll stop here. We always start off with our a, b, and c and d value. A is 3, b is 2, c and d are both, in this case, 0. No parentheses, no d. So no d value here, no c, no d. Now, the way we start off these graphs is we first start off graphing our d, that's 0. Then we graph our c. We say we're going to start at 0 here. And the next thing we do is we talk about our b. B leads us to find the period. P is equal to 2 pi over b. If you remember that formula, 2 pi over b. 2 pi over 2, which means I'm going to stop this graph at pi. I'll graph pi right here. The way I've always asked you guys to graph it, you want to do 4 tick marks, half, half, and half, 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 and half. So you end up with these 4 tick marks. And this is going to be pi over 2, pi over 4, because half of a half is a quarter. And counting 1, 2, 3, pi over 4. Okay, that's my period. Next thing we do the amplitude, which is 3, up 1, 2, 3, down 1, 2, 3. In general, I'll do these dotted lines up on top and on bottom. So to graph a sine graph, remember sine always starts at 0. So we start 0, up, 0, down, 0. So this is our sine graph. Seems pretty fast, but again, this is just a review. If I want to go to 2 pi, we go half, half, and half, and we just follow the trend of the graph. Up, 0, down, 0, up. So we're following that full wave. So these characteristics are important because as A changes, that's how tall my graph is. As B changes, that changes how long it takes me to finish the graph. It could be a really short graph, or it could be really take your time long. What we call frequency, high frequency, low frequency. So how does this relate to cosecant graphs now? Now, I want to go back and talk about what is a cosecant versus a sine graph. So if we look at sine of theta, if you remember, what sides does sine represent? Sine represents opposite over hypotenuse. Opposite over hypotenuse. Now, the way we come up with these values here is we're just taking opposite over hypotenuse. On the unit circle, let me draw the unit circle for you guys. This is going to be actually, no, a couple ways of doing that. We can just do it this way. Or this is our y value, right? This is our y value. Our y value is 0, comma 1. No, sorry, other way around. 1, comma 0, 0, comma 1. This is negative 1 over here, 0, and 0, comma negative 1. Okay. So to highlight this, our y value for sine is 0, 1, 0, negative 1, and then back to 0. 0, 1, 0, negative 1, 0. So as we go around the circle, we go 0, 1, 0, negative 1, 0. Okay, if I want to look at this on a triangle level, let me draw you guys a triangle version of this. At 0 degrees, we draw a fake triangle. It's 0, 1, 1. The sine of this triangle is equal to opposite over hypotenuse, which is 0, okay? So following along this logic here, what is cosecant? Cosecant wasn't opposite over hypotenuse, it was the reciprocal of that, and it was hypotenuse over opposite. I wonder if you guys remember that. So if I look at my triangle over here, what is the hypotenuse over opposite? The hypotenuse is of cosecant is hypotenuse is 1 over opposite of 0, and this is undefined. Okay. Why is it undefined? Why is something divided by 0 undefined? And this takes us back to something that we did all the way back in Algebra 1. Why can I never divide by 0? Why is dividing by 0 such a sin? So bad. Why is dividing by 0 so bad? And what does it mean by dividing by 0? So this is a big math idea, so I'm going to explain this right now. Why is dividing by 0 so bad? And how in the world am I supposed to graph 1 divided by 0? 0 divided by 1 is easy. That's a 0 here. Bam. Easy peasy. Fresh and easy. But what is 1 divided by 0? Now, if you take any calculator and you say 1 divided by 0, it's going to give you an error. If you try that right now, try it. It'll give you an error. Fancy calculators might say undefined, but it'll give you an error because you broke your calculator. You ever use a Windows machine or Apple machine and you did too much crap to it and all of a sudden it freezes on you? It goes, and it just freezes? Happens on your cell phone, right? And then what do? You have to do a force reset, right? And what happens is it's because you froze it. You've overtaxed its processing abilities and you kind of broke it. So here's the reason why you broke it and why it's an error. Let's use something that we do know. What is 1 divided by 1? Let's do an example here. What's some easy one? What's 1 divided by 1? That is 1. Easy, right? Now, this isn't 0, but we're going to walk our way to 0, and we're going to see what happens to this number as we get closer to 0. What's 1 divided by 0.5? How many 50 cents are in a dollar? That's what division is, and we forget this principle of division. It's how many of these guys are in the top guy. How many ones are in 1? Oh, there's only 1 of these. Okay, it fits perfectly. How many 50 cents are in a dollar? Well, that's 2. Now, if you want to see this in a fraction version, I'm not sure if you want to. 1 divided by 1/2 is 1 times 2 over 1 multiplied by the reciprocal, which is 2, and that's algebra 2. What is 1 divided by 0.25? How many quarters, please? How many quarters are in a dollar? How many quarters are in a dollar? That's going to be 4, right? And let me rewrite this as a fraction so you guys can see. 1 over 4 is 1 times 4 over 1, which is just 4, right? Okay, so math-wise it works out. We can do that with the calculator also. What if I say, keep on going with money. What's 1 divided by a dime? How many dimes are in a dollar? There are 10 dimes in $1. Let's keep on going. How many nickels are in a dollar? That's 20. How many pennies are in a dollar? We call this 100th. 100th, right? Because there are hundreds. There are 100 pennies in a dollar. How about 1,000th? How many 1,000ths are in a dollar? That's 1,000. I want you guys to see the trend here. As the denominator is getting smaller and smaller and smaller and smaller and even smaller, and as it gets even smaller, what is actually happening to my answer? It's getting bigger, right? As the denominator is getting smaller, it's getting bigger. Why is that? Why is that? And the big reason is because in division, it's how many of these get squeezed into here. And if you have smaller pieces, you can fit more into that one. You can fit more into it. So if I ask you for 1 I mean, you can only give me one of those. That's just one. But if you ask me for half, now I'm going to change this a little bit up to a story like normal. Let's take this as a slice of cake. But you're going to tell me in a weird way how big of a slice you want. Okay, I'm going to ask you, let's say, example, I'm going to ask Mo, don't need to respond, Mo. But if I ask Mo, how big of a slice of cake do you want? And Mo says, I want half the cake. That's how big the slice is. I want half the cake. So how many slices can we come up with? We can only come up with 2 slices. If I ask Mo, hey Mo, how big of a slice of cake do you want? And Mo says, I want a quarter of the cake. That's the slice. I want a quarter. So how many quarters are in my cake? How many quarters are in my cake? There are 4 quarters in my cake. If I ask Mo, hey, how big of a slice do you want? I want a small piece. I want a 1/10 of a slice. That means I can make 10 slices total. If I go to Mo, hey Mo, how big do you want a slice? You say, I want a 20th of a slice, right? This is what we call a 20th. 0.05 is a 20th. So you get 20 slices. 100th, you get 100 slices. 1,000, see how small this slice is now? Isn't that a tiny slice? You got 1,000th of a slice? Here's a little bit of cream. But what if I ask you instead, I want 0 slices? How many slices could we make from a slice size of 0? Anyone know the answer? How many slices could we come up with if my slice size was 0?
Is it a trick question? Because then there'd be none.
Not none. I could give everyone in the world a slice of cake if their slice was 0. The point is, I can give you an infinitely many set of slices. That's why it's undefined, because infinity is not a number. 0 you can't divide by 0 because you would actually end up with the number infinity. How many zeros, how many of nothing, right? If Mo says, I want a slice of nothing, how many slices of nothing can I give? I can give you a slice of nothing. I can give you a slice of nothing. I can give you a slice of nothing. How much money do I have to give to charities? Nothing. I can give nothing to all the charities in the world. And this is the idea of why 1 divided by 0 is infinity. Now, let me go ahead and show you guys this in a graph real quick on Desmos. Let's go ahead and go, whoops, wrong one. Real quick, Desmos graph. Oh, darn it, that's not Desmos. Here's Desmos. And the graph is 1 divided by x. You guys might have seen this graph before, 1 divided by x. And I want to show you just on the right side here. As x gets closer to 0, or x gets closer to 0, what happens to the y value? It shoots up. Because as x gets smaller and smaller and smaller, you end up with more y's. Till you shoot up all the way to infinity. And we can demonstrate that with our simple example here of just dividing by small numbers. So whenever you divide by 0, you actually shoot off to infinity. And infinity is not a number, right? It is not a number. It's a number that we can't ever get to. It's just kind of an idea, you could say, just like Antifa. It's just an idea. Okay. Whoops, I shouldn't have said that. They're going to cancel me on YouTube now. Okay. So here is our idea here. So if we say that cosine graphs are just the flip version of sine graphs, see how they're just the flip version of it? This is what we're going to do. Let's go back and graph our sine graph. We said y is equal to, I'm sorry, I forgot what it was. 3 sine 2x. And we graphed our A, B, C, and D. We did all this work. Okay, all this work. So 0, sorry, that was a 3, 2, and 0, 0. And we made our mark. We said this was 2 pi. No, darn it, that was pi. This was pi over 2. Okay. And we said the graph goes 0, up, 0, down, 0. That is our sine graph. Yeah, I see you, Lewis. I mean, sorry, Eddie. I see you, Eddie. Hey, Eddie. So here's my values. What is the reciprocal of 0 over 1? What's the reciprocal of, in this case, 1 over 1? What's the reciprocal of 0 over 1? What's the reciprocal of negative 1 over 1? What's the reciprocal of 0 over 1? The reciprocal is infinity. So these graphs, if I want to graph this as now as 3 cosecant of 2x, the graph looks like this. If we continue our graph, 0 up, 0 down, 0, the graph looks like finger graphs. So if I graph cosecant here, cosecant of, let's do 3 cosecant of 2x. This graph looks terrible. I need to reset this graph. Darn it. I need to reset. Let's reset. Oh, I need to change one more thing. Let me change this to pi. Step is by pi. We're going to do 3 cosecant of 2x. If we look at the graph here that we see, it is a finger graph. I call these finger graphs because it's almost like their fingers reaching in. Okay? So how are you supposed to graph these finger graphs? Is you graph instead a sine graph. 3 sine of 2x. And hopefully you can see this right now. I'm going to make this a dotted line. Now, what we do is we take our regular sine graph here. See, this is our sine graph. And instead of graphing a sine graph, we use it as a, let's say, a framework to graph our cosecant graphs. Because instead of graphing 0, see how this was a 0? We're going to shoot off to infinity. Instead of graphing 0, we're going to shoot off to infinity. Instead of graphing 0 here, we're going to shoot off to infinity, and we're going to shoot off to infinity. And that's really the difference. We're going to literally take our graph, we're going to flip it upside down. We're going to take these points and we're going to flip it upside down. Let me go ahead and screenshot this and show you what I mean. So if this was my graph going this way, I'm going to, let me go ahead and, graph is going this way, I'm going to rip it apart and I'm going to force it to go the other way. See these graphs here? I'm going to force them to go the other way. See this graph here? This is going to get forced to go the other way. Forced to go the other way. Forced to go. I'm going to flip those numbers around. Okay. So that's one of the takeaways, is that graphing a cosine graph is actually pretty easy. We just have to flip this graph around. Now, a couple things you want to pay attention to is that at the zeros, you might want to draw little tick marks, because we don't cross over them, we follow them to infinity. We don't cross over them, we follow them to infinity. Now let's go ahead and use the sine graph as example. Let's go back to a super easy one. Y is equal to sine of x. And we know the graph of sine x is 0, 1, 0, negative 1, 0. And I want to talk about the numbers that are involved here, okay? Here we go. Let me talk about the numbers that are involved. And what happens when I flip it around? So a cosine graph is just a flip version. What I mean by that? What is the flip of 0 over 1? We said the flip is 1 over 0. That's why we're shooting off to infinity. What is the flip? Let's say this is 1 over 4, right? That's a quarter. Okay, this is 1 here. We're going to pick up some numbers. This number is going to be 1/2. What's the reciprocal of 1 over 4? Isn't the reciprocal 1 over 4, 4 over 1? Aren't we way up here? What's the reciprocal of 1 over 2? It's 2 over 1, right here. If I look on this side, that's 1 over 2. That's 1 over 4. The reciprocal of 1 over 2 is 2 over 1. The reciprocal of 1 over 4 is 4 over 1. Instead of going down, the cosecant graph is the reciprocal, and it goes up instead. Why? Because at 0 here, what's the reciprocal of 0 over 1? That's 1 over 0, which leads us to what we said before, is infinity. positive infinity or negative infinity? Well, weren't these all positive values here? When I flip the reciprocal, it stays positive. But look down here. Aren't these all these negative values here? So if I flip negative 1 over 4 or negative 1 over 2, what's the reciprocal of negative 1 over 4? That's negative 4 over 1. You're way over here now. And the reciprocal of negative 1 over 2, that's going to be negative 2. So this graph goes this way. Oh, that looks a little terrible. Let me redo this. So we go this way. So let me go into the Cliff Notes version of it. If I'm going to graph y is equal to 2 cosecant of x, I will instead be graphing 2 sine of x. So we still look for a, b, c, and d, which are all the same values here. A is, b is, c, nothing has changed. That's 2, 1, 0, 0. We graph our framework like we did for a sine graph. D is 0, C is 0. Our b value is 2 pi over b is 2 pi. Half, half, and half. My a value is 2, up 2, down 2. Now, instead of graphing the sine graph, don't graph the sine graph, don't do that. Just draw the dots that you would have used for your check marks. 0, up, 0, down, 0. Are you guys comfortable with us coming up with these tick marks? 0, 1, 0, negative 1, 0. From this point, instead of graphing towards 0, you are going to graph to infinity. That is the only difference now. As this graph continues, instead of graphing towards 0, remember this is the reciprocal graph, we graph to infinity. To infinity. As this graph goes backwards, 0 going up and down, this graph goes to infinity, to infinity. I'm going to pause for just a moment. All right, let's take a look at how secant looks. If I graph a, let's say y is equal to 2 secant of, we're going to say x plus 1, okay? We said secant is the same as cosine. So that's how we're going to frame this. We're going to frame this as a cosine graph. But a, b, c, d, none of this stuff has changed. B, c, and d is 1, okay? So we're going to graph from d onward. We will start from d and move forward. D is 1. So that's our new vertical shift. We can frame this as the word midline also. This is the middle of my graph. B is my frequency leading me to period. Period is 2 pi over 1, which is just 2 pi. Nice. So that means it's going to finish at 2 pi. All right. Half, half, and half. You want half, half, and half. Make that nice. We copy our tick marks over into our new midline to make it nice and even. Right. I'm trying to give you guys some scaffolding techniques here to make sure your graph doesn't look trash. My amplitude is 2. So from the midline, we count 2 up and 2 down. So 2, if I'm on level 1 and I go up 2 spaces, I'm at 3. And if I go down 2 spaces, I'm at negative 1. So you can draw your dots if you want. A little bit dots. A little bit dots. Now, to remind yourself what cosine looks like, cosine starts at 1. So that's at my tip. 1, 0, negative 1. Oh, that's not negative 1. All the way down. Negative 1, 0, 1. So this is what my cosine graph would look like. So please don't copy this, but the cosine graph would look like this. And it would continue on the pattern. Okay, that's what the cosine would look like. But since this is the reciprocal graph, this is what we do. So pay attention. Every time we're at the tip, we go away from it. Because in our original graph, in our cosine graph, we would have headed, when we have headed toward it, look, I'll draw this using dots. So the reciprocal would head away, 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 away. Did I say away enough times? Away from R0. We would head away from the center. We would head away from the center. So you might say, Mr. Ko, hey, Mr. Ko, the reciprocal 1 over 1 isn't infinity. You're right. But it's because it's 2 secant of x plus 1. When I take the reciprocal of this guy here, it would have been 1 over 0 already. What's 1 over 0 times 2? Still infinity. What's infinity plus 1? Still infinity. Does infinity plus 1 beat infinity? No, it's infinity. Okay, that was a dumb thing. Jinx infinity. Infinity times 2. No, that's just still infinity. Okay. So our goal is to first set up the framework for our graph. Once we have our framework done, we can then run away from our graph. Run away from our graph. Run away from our graph. Once we set up the framework, we can run away from our graph. Run away from our graph. And this is the graph of secant, because it's just the reciprocal of cosine. So if you can graph a cosine, you can graph a secant. Okay, so I'm going to draw you a graph, and you're going to tell me the characteristics. Let's go the other way. I'm going to give you guys a graph. Oops. Yeah, that's fine. And then we're going to say this is pi. Okay. All right, so here is an illustration of me giving you a graph and you telling me what would the equation be. Oh, that's terrible. Sorry, that's why you always go from the center out. Okay, starting from 0, would you consider this a sine graph? Sorry, secant graph or cosecant? If you're not sure, connect the dots. I'm connecting the vertexes of these values. Does that look like a sine graph or a cosine graph? Hopefully you would say it's a cosine graph. And since it's a cosine graph, the reciprocal will be a secant graph. Okay, it's a secant. What's the amplitude? Well, first, what's the middle line? The middle line is 0. If the middle line is 0, it's 2 up and 2 down. So we know the amplitude A value is 2. What's the period? The period from 0 to pi, that's my period. If the period is pi, what is the b value? 2 pi over b. Maybe you could guess what the b value is. The b value is 2. Because 2 divided by 2. If you want to also look at this as frequency, if this is frequency to you, how many graphs would you see? How many times would you see the graph happen? You would have to see the graph happen twice by the time you hit 2 pi, because the frequency is 2. That's another way of looking at it. What's your c? C is 0. We're starting at 0. D is 0. So to write this graph, this is 2 secant, because we use cosine, right? Remember we use cosine, of 2x. That is our equation of this graph. Looking at the characteristics, A, B, C, and D.